I see we have a volunteer as a note taker. Thank you, Torlis. That's great. Appreciate you stepping up and helping out. No. You don't come to a working group to work on slides for another working group. You come to participate. You invest your time in getting this work progressed. So 3:30, we are 2 minutes late. We are supposed to start right at 3:30, and I don't see a big crowd outside the door. Door shut. Golly. Everyone scan. You scan your QR. Anyone actually participating in this working group or just here to kind of catch up there in the back of the room, Mike? Nothing.
We want to see the brick show.
This is nuts. I got some poems I could tell. I've got some silly songs to sing. You know, a grandpa now, so I've got nothing but goofy things. The poem? Oh, Sarah, Cynthia, Sylvia Stout would not take the garbage out. She washed the dishes and scrubbed the pans, cooked the yams and spiced the hams. Anyone else ready to take notes? We have a notepad tool that is just wonderful. And if you're really good, you can just take the speech to text and paste it over and pretend like you took notes. Anyone? Torlis? So do we have the presenters here is all we really have. Your IETF furniture. Okay, everyone in the right room. This is IETF 120, Vancouver, BC, MBONED. We need a note taker. As funny as this sounds, we need a note taker. Someone's got to do it. Note well, rules, standards, process, procedures, noted, nods. Love that participation. This is wonderful. Noting more and well. So Mike, what do you do for minutes?
Yeah, we don't even do note taking anymore in PIM.
You just use the voice to text?
We just use that, but we also take the time and watch the video and just do everything afterwards.
Okay. Where does the text file go? Speech to text? Does it record? Yeah, I think it might have materials or something, recordings or something there. All right, we'll dig it around. Thank you. All right, this is being recorded. Do I have to hit the record button? This session is recorded. I guess it just stops. It starts on the hour automatically now, doesn't it? Okay. Everyone QR in. Look at that, such participation. Careful, I may fall asleep. This is the agenda. Anything missing? Want to bash? Yes, Torlis, you're on there. With the same audience for the most part.
There's furniture, but still they're not again. So.
All right, I want to see a couple new jokes. Excellent. All right, Lenny, take it away. Lenny?
All
Lenny?
right.
There we go. I got the slide control, so I'll just hit the button for you once. It'll be really tough, but I think we can coordinate.
Okay. So the telemetry draft, so we have 4 active drafts in the working group. The telemetry draft has been submitted to IESG. I believe it's in the editor's queue. The other 3, anyone in the room or anybody in the who would like to provide updates, any of the authors, if Sandy, I believe you're a co-author on all 3 of them. So if you have any, if you want to share with the room, what's the latest on all 3?
Yes. For actually, from the MBONE multicast young model and the redundant ingress failover draft, we think that it's ready for last call. And for the MT Young, it's a new working group draft, and we'd like to ask for more review. Yeah.
Formal review from the Yang doctors? Is that?
Yes, and for the technical side, we think that some implementer may provide some useful information for it also. Yeah.
Gotcha. All right. Next slide, Greg. Okay. And there's 2 other new drafts for consideration, and both will be presented today. So I think we can move along to those. Or
Groovy.
who's up next?
All right, next is non-storefront and multicast and SR networks.
No, adaptive. Actually, Yishang is up first with adaptive unicast to multicast forwarding.
Is that remote? Do we have the presenter here?
Yishang?
Yeah, I'm here. Can you hear me?
Excellent. Yes, I can. Do you want to can you share the slides, or you want me to run them for you?
Can you share the slides for me? And
well, no, you can share them down below. Down below, there's share slides. You click that button, and it will give you a selection. Pick your deck, and it'll begin.
Okay.
Excellent. We see the request. A minute now. It's funny. It shows you're sharing. Oh, there it goes. Okay. Guess I had to give a approval. You must have done that when you were testing it, Lenny. All right, take it away. It's yours.
Okay. Can I start? Okay. Hello, everyone. I'm Yisung Liu from China Mobile. I will introduce the adaptive unicast to multicast forwarding mechanism on behalf of my co-authors from the China Telecom and new H3C and ZTE and Rijie. Firstly, I will introduce the background of this mechanism. Currently, as we know that for many internet services, there are point to multi-point scenarios, especially for the live videos. But the internet service systems always don't support the multicast. So because they need large-scale renovation for the multicast transformation, but they lack the driven power to upgrade the head-end system and the end user through the unicast forwarding. So the bandwidth pressure on the carrier network is enormous. So for the same internet service, like the video, like the live video, we have the redundant traffic. So there are thousands, even millions of identical unicast traffic between the ad service nodes and the end users. So in the carrier network, there are thousands of the same unicast traffic. So it will occupy the bandwidth of other service traffic, and it will also it will limit the quality of the internet service like this. For this situation, we want to propose a new mechanism for the adaptive unicast to the multicast forwarding. So firstly, we define the device role in the mechanism. So when the carrier network can offer the multicast capability, we mean it means that the multicast domain network and the ingress PE of the multicast domain for the edge device located on the internet service server side of the carrier network act as the device of the multicast sender side. It will identify the characteristics of the service traffic. It will find the traffic suitable for the multicast, and it will convert the unicast packets into the multicast based on their characteristics and forward them along the multicast forwarding path. And for the egress PE of the multicast domain, and it will it will be edge device located on the terminal user side of the carrier network, and it will act as the device of the multicast receiver side, and it will convert the multicast packets back to the unicast and then send them one by one to the end users on the unicast forwarding path. So next, I will introduce the mechanism briefly. And first, we will configure the adaptive optimization policy on the ingress PE. And that means that we will specify the mapping relationship for the unicast flow characteristics and the multicast IP address. That will be distribution the policy that will be distributed the policy by the controller, and the ingress PE forwards the service traffic along the unicast forwarding path firstly, and after receiving the stable service traffic with the specified characteristics, that means we can make the decision by the last time for the traffic or the users for the traffic, and the ingress PE can send the notification to the ingress PE to trigger the egress PE to send the multicast join request, and the egress PE, and at the same time, the egress PE will add the mapping relationship entry and send the multicast join request to the egress PE. The ingress PE will and in the multicast domain network, it will establish the multicast tree. And when the ingress PE it can continue to receive the continuously receive the unicast packet, and when the multicast tree have established, and it will convert the packet the destination IP based on the mapping relationship, and it will send the traffic for the multicast packet, and it will send the traffic to the egress PE along the multicast forwarding path. And the egress PE will restore the unicast destination IP based on the mapping relationship, and it continues to unicast the forwarding to the user and one by one, because the multicast to map to a unicast in the egress PE is one to map n. So for the packet forwarding process in this mechanism, firstly, after receiving the packet from the user, the ingress PE will identify the unicast packets, which will need to convert to the multicast based on the flow characteristics. And the ingress PE will find the mapping relationship table and replace the destination IP with a multicast group address and convert the identified unicast into the corresponding multicast traffic from the unicast to the multicast. And according to the updated destination IP, that means the multicast address ingress PE will forward the message on the multicast forwarding path. And in the egress PE, and receive the after receiving the multicast traffic, and the egress PE will replay the destination IP with the end user unicast IP, and restore the multicast traffic to unicast traffic one by one to all of the users, and based on the mapping relationship. And the egress PE will send the unicast traffic to the user. For the how to identify the unicast traffic, we have a primary idea about the we can use the 5 tuple like the source and the destination IP and the source and the destination port and the protocol number, or other field in the packet, like the DSCP or the service ID, like APN ID or the similar one. This is the mapping relationship table, and this table for the adaptive unicast to multicast forwarding records, and that will map the unicast flow characteristics and the user IP and the multicast group address. The mapping relationship table will record on all of the edge device of the multicast domain device that include the ingress PE and the egress PEs. So we will invite the guys who are interested in this draft to join us, and welcome questions and comments. That's all. Thank you.
Questions? I don't see anyone at the queue. This is Greg as chair. Just curious, do you have a description somewhere that describes your problem statement that can't be resolved with AMT that needs a solution like this?
This solution is different from the AMT. AMT wants the multicast through the unicast network. This mechanism solve the problem that the unicast through the multicast network.
I'll look at the transcript. I couldn't follow all that. Torles? let everyone remote know that Torlis is the one that dropped the mic?
Physically, not metaphorically.
Now he's going to kick it down the aisles. There you go.
So can you go back to your overview slide with the topology, please?
This one?
No, the first one. Right. Now the one where you're showing unicast.
Unicast, the
The
unicast
first slide
from-
with the graphic. The first slide with this topology graphic. The one where
Yeah,
you're
yeah.
showing a lot of unicast flows.
Yeah. This figure is not suitable for this. No. This because
Yeah,
this one.
Right. So do I understand it correctly that in this picture, even though unicast is being used, the receivers are all receiving the same data, the same video?
The same date for the unicast to the users and in the network for the carrier. There are many of the identical unicast traffic that is,
Right. So
uh,
with this actually not being real unicast, but just multicast that is being sent as unicast to every receiver, the way to interpret what Greg was saying is you simply do multicast all the way up to the egress PE. And on the egress PE, you're setting up AMT tunnel head ends so that the last hop from the egress PEs to the users that cannot, for example, not do multicast, that is getting the multicast tunneled over unicast, right? But then you don't need to do anything new on the ingress PE. You just do normal multicast there. Because otherwise, the whole point is you wouldn't know with all your setup anyhow which of these flow carry the same content, right? If they all start out as separate unicasts, how would you know what they are, right? So you're making a transition from this picture to the picture where you're magically assuming now I'm doing multicast, without explaining how you would know from these different unicast flow how they're multicast. So in your solution, you're sending normal multicast that was never unicast, but in the end, you simply can tunnel it over unicast with AM to get through the receivers.
This situation is that the internet service system and the user cannot run the multicast, and only the network can run the multicast.
Thank you. Sanity, just want to ask some question from Torres, because this structure is the solution, not the solution. It wants to point out that we can use the multicast capability for some duplicate content transfer in the network. So, such as the live broadcasting in the network. So the same content has been delivered point to point to every receiver. So the bandwidth of the network is waste. So we'd like to use the multicast capability of the network to solve this problem. But as you said, the ingress P may be simplified because they just copy the packet for multicast transferring in the network. But the receiver side, the outer PE must know which user or the receiver we must recognize and return the content to unicast or something else to the receiver. So, but this is only a try. It's not the finally solution. So we'd like to bring it to discussion because the multicast capability open is what the operators want. So we want to provide some discussion for it.
So 10, 12 years ago, there were products in the industry. For example, if you take consideration PE down to, well, not a number, the PE that sits in front of user 2 and user 3, right? So single link, but the same video goes twice over it as unicast. So what basically vendors build as proprietary optimization solutions, they were doing deduplication. They recognized duplicate application data and only send it once and then started to duplicate it on the other end as well. So, you know, all the crazy things that people did when they didn't start out the right way. Now, obviously that stuff started to fail very quickly when encryption came along. So if you're really starting to say there is an internet service system that sends out all these encrypted unicast flows, then good luck in recognizing which of them are duplicated and could be converted into multicast. So I think maybe take it to the list or so for further discussions. But
Right. I just want to address that. I'll take the next question if you hand it, Sandy. But my question specifically wasn't how they're different. We understand they're different. The question is, what is the use case where AMT won't work? Like, I'd like to see a breakdown of something like, well, we have AMT and it does this and that. There's a specific deployment where it doesn't work and we need a new set of tools.
In my opinion, it's the reverse direction of TDN or AMT. Because in some network can't support multicast, we use AMT here, right? And but in these scenarios, we'd like to use multicast instead of unicast. So it's not the same. So if we can use AMT for all the users, it's okay. It's really okay in this figure. But if we'd like to use multicast in the core network, so there are some different. So we must do something between the ingress router and the egress router. So maybe
Yeah,
some mapping relationship or something else. Yeah.
Again, if it was multicast from the source, you can encap anywhere along the way. You can have AMT services within a domain. You can have an anycast AMT service at the edge. We've actually had deployments that did this in various stages. And so I'm trying to understand specifically. I mean, if you have unicast only content you're trying to replicate, that's a whole different problem than taking multicast across a unicast network. All right, Jeffrey. Actually, Omar's next. Omar, go ahead.
Yeah, thank you for the presentation, Song. Curious, very interested in your system because we've been working on a very similar problem. And you know, I'm want to know kind of what kind of applications you guys are using this with. Is it like for real-time media transport? Like, how are you able to actually infer what the video stream is and the application context to map a unicast or multiple unicast streams to a single multicast to collapse all the traffic? So I think it's a similar question that came up before.
Jeffrey, you had a question? Go ahead.
So I just try to answer Greg's question. So in the AMT or TDN case, the traffic is sourced as multicast. And here, the traffic is sourced as unicast. But indeed, Torres has a very good question. How does the ingress PE realize that all those 4 copies are actually the same multicast, the same content that can be combined and replaced by a single multicast? That is indeed a very good question.
That's my question.
Sure.
Thank you.
That's what we want to discuss here because there must be some feature or some attribute in the flow so it can be recognized by the ingress PE, so he can know that this flow can be multicast or other than unicast, right?
Other questions? Step through. Is this a zero draft? Is this a zero draft?
Yeah, this is the initial draft.
Is your intention for adoption?
And not ready. I think.
Okay. Well, I mean, yeah, present again. We can take a vote next time if that's what you want. If you're ready now, we can. But it looks like if you think you want to cook it more, then that's fine. We're still here. Okay. Next is Jeffrey. So can you unshare this deck? And I will take it over. It's you, right?
Okay, yeah,
You can see,
thanks.
oh, good.
All right. So this is about multicast options in a segment routing network. Specifically, it's non-source routed options. The draft was originally home in the PIM working group, and I presented once there in the last IETF meeting. Later, we realized that because we're talking about deployment options, MBONED is actually a better place for it. So we resubmitted as an MBONED document, and here I'm presenting again on behalf of my co-authors. Next slide, please. So this is an informational draft for discussions and considerations. As a long time ago, we have another draft. It's replaced that, and then rehoned from the PIM working group. We do not consider source routed options in this draft, not because they are not good. It's simply just in this one, we only consider the non-source routed options. And beer is considered here. We don't consider it as a source routed. The bit string does encode the list of the edge routers that need to receive the traffic, but it does not encode the tree or subtree. So we don't consider that as source routed. Next slide, please. So to talk about the options for multicast in the SR networks, let's first start examining the SR principles. The number one principle of segment routing is that we do not maintain per flow or per tunnel states in the network. Instead, we encode loose or strict paths in the packets themselves. The second principle, or more accurately, the second characteristics, is that optional use of controllers. The ingress routers may be instructed by its controllers on how the packet should be steered to get basically a segment list in the package to be embedded in the package so that they can forward. Next slide, please. So when you consider the principle number one of no per flow per tunnel state, then there are two options. The first one is ingress replication. It is simple, mature, but it is not efficient in terms of replication. It does apply to certain scenarios. For example, you have low rates, low fan outs, and sporadic flows. It works well. In this case, you can use both SR or non-SR paths, whether it's IP tunnel, MPLS tunnel, or SRv6 paths, things like that. The second option is BIR, bit index explicit replication. It does provide efficient replication without the per tree state. And it sticks to the SR principle number one perfectly. So it's a perfect solution for SR multicast. It works for all situations, though where you have convergence under scale requirement, and that will benefit the most. Interestingly, both the ingress replication and BIR, they are developed independently of SR, yet they are the good solutions sticking to the SR principle number one. Next slide, please. So BIR, we have made good progress, protocol progress in IETF. The base architecture, encapsulation, and signaling extensions, they became RFIs relatively quickly. And we have also other extensions and brownfield deployment solutions in the work. The deployment of BIR has been somewhat limited due to this chicken-egg dilemma, because it involves new encapsulation, new forwarding paradigm, which requires either programmable or new ASICs. So while operators are very interested in beer, they back off once they realize that their platforms won't be able to support beer for a while. And once they back off, the vendors also back off. So because of that, deployment has not been ideal. However, we believe that the prime time for beer is actually coming. We have pioneering vendors and operators that will work together to break this dilemma. Specifically, there is ASIC capability from several major vendors across edge, access, and core platforms. And we have demonstrated the interop among major vendors in the IETF and in the industry interop testing events. Next slide, please. So now if you look at principle number 2 of segment routing, which is use of controllers. In this case, there are 2 options. One is controller calculated trees. The controller will do the calculation, figure out what a multicast tree is like, and then it will use the traditional signaling to set up the tree. For example, the controller sends the calculation result to the tunnel ingress, and tunnel ingress can just use RCP, TE, P2MP to set up that tree. A more advanced option is that controller not only does the calculation, it actually does the signaling as well. Specifically, we have SRP2MP, which the PIM working group has been working on, PIM SRP2MP policy. Another option is just to use BGP to signal from controllers to set up MLTP trees or IP multicast trees. We have a best working group document on this one. So we talk about is BGP signaling, yet we have MLDP here. So here the only relevance to MLDP is use of the MLDP FAC as a tree identifier. We actually don't use the LDP or MLDP for signaling. This is actually a good option for transitioning from traditional MPOS, traditional MLDP-based deployment. Next slide, please. Some SRP2MP considerations here. So we could have MPOS data plane or SRv6 data plane. In the case of MPOS data plane, SRP2MP is actually very similar to MLDP or RCVP P2MP. Specifically, the tree nodes, they have identical per tunnel forwarding states as the MLDP or RCVP P2MP. You basically have label in and label out. The difference is in the control plane. You have different tree identifiers and you have different signaling. Another thing to point out is that SRP2MP avoids tree states on the non-replication nodes. You only need the tree state on the replication nodes. This is good for the sparse replication situations. I also want to point out that PIM and MLDP supports that as well. For example, you could have PIM adjacencies over tunnels. You have MLDP signaling over targeted sessions. However, to do that is a bit of a hassle. And in case of the SRP2MP, this is avoided by that use of that guardbox controller. Next slide, please. And then in the case of SR-basic data plane, the tree node state is actually also like the MPOS case. In the MPOS case, the incoming and outgoing tree identifying label now corresponds to the functional bits in the SRv6 destination address. And the locator in SRv6 destination address gets the packet to a downstream tree node. And that is just like the base tunnel that gets the packet from one tree node to another. So you can see that it's actually very similar. And then we can also use segment routing header to explicitly steer the packet between the two tree nodes. One catch here is that with SRv6 P2MP, each tree node needs to update the destination address, and that is different from the IPv6 multicast. So again, this does need a new ASICs or programmable ASIC to support SRv6 P2MP. Even on the other hand, if you have a router that supports SRv6 unicast, it's likely that that can support SRv6 P2MP as well. But you have some older ASICs that is at SRv6 incapable, then you're out of luck. So in this case, the pure traditional IPv6 multicast can be used here equally well. Next slide, please. Also, traditional solutions also still works in the SR network, whether it's ingress replication or PIM or P2MP, MLD P2MP, RCP P2MP, as long as they address the use case without pain points. In the SRv6 case, you may just use the plain old IPv6 multicast instead of SRv6 P2MP. In particular, even though the SR removes the need for LDP or RCP on the unicast side, then you can still use MLDP or even RCP P2MP for multicast purpose only, unless some operators, they just prefer that once I stop using LDP or RCP for unicast, I would just want to get rid of MLDP or RCP for P2MP entirely. That's operator's preference or choice of taste, and that's fine. Next slide, please. So this is a summary of the order of considerations that one can do when they consider what they need to do for SR network when it comes to multicast. The first thing to consider is beer. If you want to have efficient replication without the per tree state, and most of your replication nodes supports beer, then beer is no doubt the best solution here. Now, if you cannot do beer, or if you don't care about the benefit of beer, you can consider traditional multicast solutions, as long as they address your needs without pain points. For example, you don't care about use of controllers, and you are fine with running MLDP or PIM, even though you no longer use LDP or RCP for unicast. You can still use that for multicast purposes. That's fine. But if you really don't want to do that, and you really want to use a controller, then of course you can use controller signal multicast. It could be SRP2MP, SRv6 P2MP, or you could also just use BGP to signal the MLDB tunnels or IP multicast. In fact, in a non-MPLS IPv6 networks, the PIM controller signal IPv6 multicast is a very good choice, a very good alternative to the SRv6 P2MP. Next slide, please. So we would like to invite discussions, comments. We presented in the PIM working group. There have been no follow-up on the mailing list. We want to trigger the discussion, get the feedback, and if we see that more people agree with this summary, with these options, then we can consider the working group adoption. But at this step, discussions.
All right, Torlis.
Thank you. Yeah, I have no strong opinions. If this is going to move forward, I'd obviously love to see BRTE being mentioned, and I'd be happy to see, what text might be appropriate for that as well.
Thank you.
All right. Any other questions? So is the expectation to begin discussion on this list or combined with PIM?
This and combined with PIM.
Okay, excellent. Thank you, Jeffrey. All right, next. Last presentation. No, it isn't. It's the Torlis presentation.
Oh, I can break another microphone.
So who was in the PIM working group?
Who was not in the PIM working group? Okay, the rest of you could put your heads down.
No, I mean, so this is basically, well, I can say one new thing. How about, what is it, bartering? So if you review this draft, I'll review one of your drafts, but roughly same page. Don't give me a 500-page document. No, so I mean, I'm just coming to MBONE with this, even though I was just presenting in PIM, just to make sure that the MBONE community also knows this is one of our, basic update, the core specifications of multicast in the IETF. And so hopefully we're going to go in PIM in working group last call very quickly. So, reviews from operators also would be very highly welcome. Next slide. Right, so RFC 1112, original IP multicast specification for the host stack, right? So nobody needs to know what a router is. This is only about, how to send and receive multicast packets, the stack, the Ethernet mapping, and then the wonderful protocol called IGMP version 1. And that actually fell over our head. Even recently when, vendors of IoT equipment were saying, hey, we implemented the most full standard multicast protocol, which is IGMP version 1, because 1112 is full standard and V2 and V3 are not. And so we needed to really fix this. So how do we throw away IGMP version 1 without throwing away the specification of IP multicast? Coming up with a BIS that doesn't have the IGMP version 1 code anymore, but then update the basic multicast specification with only all the things that the IETF would like to see. So we've been on that for, I think, 2 years now. That's why I think we're also finished. And the most important things, of course, was to update that multicast is now called ASM multicast. It's also, we think, a great full standard, but not over the internet, but in controlled networks. There's a pointer to the RFC we wrote about that, right? So that's SSM otherwise. We also don't want to see any new use of IGMP version 1, but don't want to change any line of code in the billion of devices that have IGMP v2 and v3 deployed, right? So that, of course, also is a little bit tricky. We did that. Then, of course, new must and should, right? So 1112 really precedes any IETF process, right? So, I mean, all the things that we need to do nowadays with the templates and disclaimers and all that stuff. So, yeah, that was a lot of fun adding that. And then as a bonus, of course, it was also very easy to add what annoyed me as an IPv6 fan for eternities, which we never had an actual RFC saying here is IP multicast for IPv6, right? So the only stuff they did was kind of having various different RFCs where they added the code points like, oh, here's the Ethernet prefix for IPv6 multicast. Oh, and here in a big unicast document, here is multicast addresses, but you can look through all the IPv6 RFCs and won't find a real specification. What is the bloody host stack for IPv6 multicast, right? So references for that is all in there. Yeah, term ASM and SSM. Next slide. So, yeah, we're ready. So IANA early review, that was also going through all the bloody IANA registries, trying to figure out which 1112 references to update. IGMP version 1 headers, specific case, but in the end, it should be really easy to review and compare against the original with IDDiff tool. Appendix A was IGMP version 1, that's gone. There are a bunch of appendixes and explanations in there, but the main text really maintains the wonderful style of Steve Deering with just many places small new v6 references, must, should, ASM, SSM. So hopefully this should be an easy way to score review points that I'm happy to return. Thank you.
Questions, comments? I asked for new jokes. I didn't get any.
No,
Sorry.
I'm sorry.
All right, next is our remote presenter, Omar. Oh, okay, I did. It's all yours now.
Thank you. I'm still waiting on the slides. There we go.
Did you just select that, Lenny?
All right. I did.
Okay, gotcha. My mouse was on the way. It ran off.
Beat you to it.
All right, take it away, Omar.
Thank you. So, talking about open casting and multicast CDNs and architectures that we've been developing for them. Network operators are facing unprecedented challenges. A number of presenters have talked today about a flood of unicast traffic from streaming video and downloads from commercial CDNs. Operators are struggling how to keep their users happy and deliver higher bit rates and maintain a high quality experience, and how to have a return on investment in all the infrastructure that they're building, and how to actually scale up the number of users that they're able to serve. It's challenging. It's a unicast OTTs world. All the apps in the world that people are using are HTTP based, and more people are watching video over web than they are over broadcast, which is purposely made for this use case and much more efficient at it. And it's really hard to get OTTs to embrace more efficient modes of delivery, especially when multicast is unroutable over ISP networks. Unicast infrastructure is very exclusive, and there are just the state of affairs with access to that infrastructure means that it's really hard to get it deep into the network where it's able to anticipate surges and so forth. And that's because of the settlement-free peering model, and people, commercial CDNs and private CDNs giving appliances to people and to operators who are serving significant traffic that it's worth giving infrastructure to, and also means that these operators are not able to monetize on that capacity. So to address these challenges, there's a lot to it. We'll try to go through it, as high level as possible, but it's a combination of, technology and business problems. And, fundamentally it's like, multicast is purposely made for video, and, that's kind of what is, in our mind, and I'm sure in this setting here, people's are very clear about. We need to get multicast to scale the delivery of these services, and we need more edge caching to be able to use and time shift traffic that is multicasted. Another big part is, okay, you have these appliances there. There need to be a way for OTTs to interact with them. So I'll be talking a little bit about open caching, which is another IETF project and aimed at allowing for operators and mobile CDNs and commercial CDNs to offer standard interfaces to OTTs and content providers. And finally, you have all these independent CDNs. You need a way to enable access to them, and we're building protocols and primitives to commercialize that capacity. So first of all is, we have this chicken and egg problem. There are no multicast enabled services, and it's really hard to get all the app developers in the world to switch over to multicast, to integrate an SDK, and there isn't really a multicast network for them to get a return on that investment. Our view on it is that it has to be a separate appliance, and that's what this multicast adaptive HTTP proxy is. It's a single appliance for transparent caching and multicast delivery. An unmodified user agent and device player that is expecting to talk to a server, an origin server over HTTP, can use this adaptive proxy, and there's a part of it we call the gateway side, and part of it that's the server, and they're going over some bottleneck link. The request for the user, regular HTTP, goes to the multicast gateway, which has a cache. If it's there in the cache, it's served directly, but if not, transparently forwards that request to the server, and the server goes out to the origin, retrieves a response, and delivers it back synchronously to the gateway, and to any other concurrent gateway. They can use that stream in real time, or cache and time shift it for use later. And this is significant, also the fact that we're doing, there's a little green lock there. There are other systems that do this, like DVB MABR, ATSC3. These are over-the-air standards for digital video broadcast and television. They define ways for packaging HTTP video over multicast, but they're quite cumbersome, and most vendors, and solutions that are out there, including MABR, it's designed for to be configured and integrated into apps. So this is transparent to the app developer. And how does traffic actually route to that player, you wonder? And that's where open casting comes into play. Open casting is a new project that is being driven by the Streaming Video Technology Alliance. They're an industry association that was started by a number of OTTs who, are kind of later to the streaming war, so didn't have their own CDN infrastructure, and we're looking for ways in which they can have more capacity and tap into ISPs who can run CDNs themselves, and use that infrastructure with a common set of interfaces, regardless of who the CDN is. So open caching is meant really for unicast traffic. Initially, you have the UCDN. The UCDN is a commercial CDN, or it could be the content provider themselves. Disney, for instance, is one of the founding members of the Streaming Video Technology Alliance, and they would operate in that UCDN role. And they can delegate requests to downstream CDNs. So this is all outlined kind of in RFC 6706, which is the problem statement of CDNI. There are a number of different interfaces. There are actually a lot of interfaces that make this all work together. But the core idea is that the user agent, the user app, makes a request to Disney.com, and they run what's called a request router. That request router has a number of downstream CDNs that they're in their registry, and they use CDN interconnect to forward that and delegate that request to one of their downstreams. That downstream then can, based off of the parameters of that request, determine which node to redirect the user to. So that can be either, there's two types of redirect. It can be either HTTP 303, or it can be a DNS-based delegation. So if we're seeing a request coming from /32, where that DCDN operating this infrastructure has knowledge that the user has an appliance within their LAN that can receive these requests and handle that traffic, will redirect them to that appliance. Then that appliance, let's say they're now redirected to the map gateway, will, like I showed in the previous slide, make the requests to the gateway, and the gateway connects to the server. The server is able to forward requests coming from, the upstream CDN. So open casting is an extension of this caching configurations and interfaces that is extending it for better multicast support. So how we can do actual service discovery, management of resources and the actual circuits that have been provisioned, and also allow the upstream to define which endpoints they want to enable to multicast, under what conditions, and so forth. Oops, too many slides. So you have this infrastructure, a CDN that's being operated by the MNO or the ISP, and it has some varying levels of multicast routability. We're implemented at the app layer and the transport layer, and what actually is connecting between the server and the gateway is, we're pretty flexible. And we're initially thinking about this from, the perspective of going over the air because of the routability challenges. So ATSC3 is the next generation of television that's being rolled out here in the US and a number of other countries. Today is announced that Brazil is also rolling out ATSC3. But one of the big deals about it is that it's IP native. Similar to the transition from 3G to 4G, it's an IP native network. So we can skip over all of the routability challenges going directly over the air to the end user. And we can use their TV sets. Their smart TVs have tuners in them and are effectively small computers. So we can run the gateway directly on on-prem and overcome these routing challenges. I've learned a lot more about AMT in recent months and TreeDN, and that's had me thinking a lot more about multicast backbone. So we've been implementing AMT functionalities, and actually there's been a lot of interest in that we can use. We're also deploying this in people's homes and kind of creating an open CDN that anyone can maintain an SLA and prove that they're able to serve capacity with high QoE, can relay their traffic. So having an AMT system part of this network is really interesting for overcoming kind of gaps in multicast routability into walled gardens or pockets of an ISP network that are multicast routable. And the idea that we've been experimenting with is having an AMT gateway, part of our multicast gateway, that can essentially relay, decapsulate and relay that multicast traffic onto that subnet or that part of the network that is multicast routable, and that other users can efficiently use that stream that's being relayed without needing any OTA hardware. So this opens up a much larger footprint than what we can do over the air. And for parts of for users who don't have the gateway on-prem, these nodes still fall back to unicast. So yeah, we have the ability to scale the availability of multicast services into parts of ISP networks that couldn't get services there before. And we're building this as an overlay network. And, you know, content providers like Disney have, you know, been the #1 supporters of open caching, but it's still challenging to work with a large number of vendors. And the idea is to create a single overlay network that abstracts away the complexities of what is the underlying transport, and offering multicast, regardless of if it's over, you know, TDN, a terrestrial OTA broadcast, satellite broadcast, 4G, 5G, MBMS as CDN interfaces, and that home users or small businesses, landlords and MDUs can run the receiving nodes, you know, and essentially scale out traffic in those parts of the network. And you know, this is also, you know, and running it as a rev share effectively, enabling for lower capital requirements for building out this infrastructure, and lower operating costs, getting nodes into locations they couldn't, you know, do so before without having to pay rent. So it's a win-win. How this overlay works is we're building what we're calling the capacity marketplace. And this is a set of interfaces built on top of CDNI that brings in the missing coordination layer for the capacity consumers to leverage capacity providers. So one of the big challenges, yeah, you have these protocols, and we have folks here from mobile operators who can relate with the challenges of core interconnect. So every time you want to set up a new core, it requires both parties to you know, work together, and there's a lot of security challenges and trust that has to go into enabling access to these services. So this is you know, a project leveraging, you know, a immutable ledger or blockchain and smart contracts. And you know, there have been similar efforts in 3GPP to use blockchain for you know, simplifying and making interconnections more trustworthy. So I'm coming actually from that background, and you know, have worked on core interconnect. You know, one of the authors of the Magma open source core project, making interconnect easy. And you know, there's a much bigger and much clearer value proposition for it in CDN interconnection than there is in you know, cellular and 3GPP core interconnect. But it has not received nearly the amount of attention or love. So this is the architecture, and you know, it involves essentially a registration layer for both participants, and you know, we vet on the supply side the providers there, that you know, they also are responsible for keeping track of their KPIs and capacities, and we have you know, primitives that we've built and utilities that allow them to report this in a way that's not gameable. There's the market layer that allows for the capacity consumers to put in requests for capacity where they want it, effectively a footprint. You know, that can be an ASN, it can be a list of subnets, geography, and they say, I need, you know, 100 gigabits per second on July 26 in the Eastern US. All the providers get that bid and can programmatically respond with their offers if it's below the asking price. If the provider, sorry, if the consumer lowballs and, you know, that's you know, they'll get no offers and they need to revise their request to get offers. So there's this back and forth that goes between, you know, both sides of the market. And once there's an offer that is agreeable, it's executed. And, you know, we create smart contracts that enable us to, you know, monitor SLAs, enforce them, and track usage. And we then make the bootstrap credentials that are necessary for CDNI to happen. And those credentials are given to the consumer. And then the CDNI standard APIs take over at that point. The capacity side, the supply side will be reporting their proofs of delivery and usage logs. And, you know, there's some settlement that happens after the fact. So yeah, I think I skipped over a little bit of the architectural components, but, you know, we're built security and authentication primitives that nodes verify for multicast using Tesla. It's and also an RFC. I'll tell you its number 4082. So we have a variant of that. We provide source integrity and authentication, and you know, the nodes report that they've received that signal, so we're able to confirm delivery of multicast services. Unicast delivery, you know, we contributed a interface at IETF 118 that allows for you know, billing and kind of logging of requests in a verifiable manner for downstream CDNs. So that's it at a high level. I will open it up for any questions.
Yeah, we got 2 people in the queue. The man with no tour, please.
Can you go back to the oh, thank you very much, by the way. Unfortunately, this was kind of a whole other universe flowing over my head. Unfortunately, there is no draft, so we'll have to torture you here with Q&As on these slides. But yeah, so it's very hard to present something as big as that. Can you go back to the previous slide with the picture?
Yes.
No, the one that you had showed last. It was one of the initial slides. This one, yeah. So AMT is fine. Where would you actually start doing any in-network replication, you know, something between the origin server and the individual receiver? Where is replication happening?
The multicast server is the box on the left. So it's receiving requests from gateways, or it's been pre-programmed to push out a particular HTTP video manifest. So it's doing all of the replication, so to speak. There's also another point of replication. So
wait a second, slowly. Let's take one example. So you're saying a DAB MABR as one of the example cases, right?
Mm-hmm.
So that is already some multicast system, right? So DVB uses multicast for the satellite. So you're basically feeding something into that existing multicast system. Is that a correct interpretation?
Well, we implement the DVB MABR interfaces. So, you know, our multicast system is, you know, we're abstracting away the underlying complexities of the PHY to the users of the multicast service. And yeah, MABR is one example of the system that we'd want to use and has.
So wait a second, has DVB specified MABR? That's their specification, right? I mean, there's also DOCSIS MABR, correct?
Yeah, MABR is you know, it's
Are you
really
with the term DVB MABR? Are you referring to a DVB specification there, or something else that you invented?
We implement the DVB MABR specification. We can. So, DVB MABR is meant for live television and linear television. So, we can use those existing systems and, broadcast infrastructure, the satellites, we can use all of that. And there is some on the receive side to use OTTs. It does require our gateway. So it's not, if you want to do, what we're doing with OTT app, translation, that isn't going to work on your TV channel and your TV guide. But we're using the same PHY, and we're working with vendors who are producing set-top boxes with DVB
Sorry,
receiver.
you're very fast there, right? So I'm trying to understand when you're jumping from one possible path to describing 5 or 6 possible delivery path in parallel. So I would just love to understand a single one first and how it's.
We're talking about DVB still. So, with DVB MABR, it's meant for linear live television, which does not work for Netflix, does not work for downloading software updates. Yep. So if you want to use your existing set-top box, it's not going to work with what we're building here. We require that on the user's app, on the user's television set, they download an additional Android app that can use the multicast feed coming over the DVB PHY, and it's a variant of the MABR spec that allows.
So, I mean, you're having a picture there of a satellite transmission, right? Are you? I mean, are you implying that the new content that you're bringing into DVB from your system goes over existing satellite connections?
Yes. So we're treating it as a PHY, and we have our own proprietary transport.
So, but then the operator of the DVB MABR would pretty much have to set aside some transponders for your new content.
Not necessarily. We can be allocated on a logical channel. Okay. So transponder.
But basically he needs to set aside bits for it, whether it's a new transponder or you're mixing it as channels into existing DVB transponder. Sure. You're basically translating it at that DVB MABR head end into a DVB stream that goes through a standard DVB system. But on the receiver side, there is a special, software that goes beyond than the standard DVB reception, so that it can, for example, receive new, still broadcasted channels, right? I mean, when you're saying it could do something like Netflix, that's more like a unicast, right? So, or
exactly. So
the
idea is that we're using existing infrastructure on the broadcast side. And on the user side, that there's a new application that's deployed that receives these multicast signals and runs a unicast HTTP server on-prem within the user's television set, within wherever that point of presence is. It's able to receive over multicast and convert back to HTTP so that an unmodified application can use those deliveries over.
What would be the content example, right? You said something like Netflix. Is this the last thing?
Yeah, we have other people in the queue behind you. That's
okay,
all.
Yeah. No,
it's not just a Torla show.
He can kick me if he wants me out, and Lenny is far away, so. No, but seriously, as far as the content is concerned, right? How do I imagine something like a Netflix being injected here with your system over satellite that only has limited additional bandwidth? Is that kind of the most popular Netflix as pay-per-view, or what's kind of the content model here?
That's a great question. So that's where open casting is coming in, and the OTT. Netflix is not a member of SVTA, unfortunately. Hopefully one day they do. But whoever implements the interface of UCDN or one of the vendors and the CDN essentially is using one of the open caching CDNs. We're running one as well, and they program how they want that service to be delivered over multicast. So that's the idea of open casting. You map different streams to multicast sessions and channels, like you would a CDN service.
Mr. McBride.
Hi, Mike McBride, FutureWay. Thank you so much, Omar. Very interesting. Anything multicast related, I get interested in. And then when you mention blockchain or smart contracts, I get all giddy. So I got a question about that. It may be a small part of what you're describing here, but just wanted to pursue that just a little bit. And if there's some pointers maybe that you have that I can read about later, that'd be great. I try to do a quick search on it. But so my understanding with the blockchain piece of it is that you're using that for SLAs, as you mentioned, and it would just be helpful to understand that a little bit more. Like, are you using some sort of like hyperledger or some proof of work kind of a thing to do that?
I'm happy to follow up with you on more of the primitives that we're building. SLAs is a really interesting one. So there are new ways in which we can essentially penalize participants. We ask them to put in a deposit. So to participate in the network, you have a deposit, and if you violate the SLA, you're penalized. So that's how it's enforced, and then the conditions are based off of uptime or the capacity. That's faking your capacity, for instance, and trying to game how we are reporting essentially the amount of capacity you have. So it's meant to keep actors honest. It's one of the mechanisms that we're using. A big thing also about it is kind of trusted hardware. So a big thing is verified boot and making sure that nodes are not tampered with, running any malware, and using the smart contracts to enforce that behavior.
Yeah, that's fascinating. I'll probably just get your email maybe from Lenny to maybe follow up on more about that. I've been thinking about a draft for MBONE for a while now that has to do with using blockchain to enforce all sorts of things that are more networking related. So it'd be really fascinating to find out more about what you're doing with that with SLAs.
Yeah, I'd love to connect.
Thank you.
Thank you.
Lenny?
Yeah, almost. So the first question, two quick questions. One, the open casting spec in SVTA, is it specifying TreeDN as the multicast network between this multicast server and the gateway? And if not, how could we add it to that? How could it be added to that? Because I think, obviously it can be very beneficial to that architecture in that it can extend the reach of where that multicast gateway can be. It can be anywhere on the internet, not just connected to a multicast network. So
yeah, that's something we can definitely do. The open casting project is a follow-up on really rudimentary multicast capabilities that were introduced in open caching. Already, right now in open caching, you can advertise as a footprint. So you're, as a CDN, you have US West, you have US East, and you're advertising different footprints that have different capabilities. And there are metadata objects that are exposed by the open caching or CD9 controller that include a parameter about multicast. So that is, it's like multicast is possible. And it started off as just satellite. That was the only descriptor we had, but we expanded that to DDB, ATSC, like we've expanded it to all the OTAs, and I think we should expand that to include TreatyN so that an operator can advertise the kind of footprints that they have and understand, just kind of the infrastructure that they're using, and that gives them a good sense of the reach. Open casting is coming in to add in more exposure to the consumer, the OTT, about the multicast services that are being offered. Thresholds. So a particular endpoint can be normally served over unicast, except if it has a certain number of concurrent viewers, in which we switch them over to multicast. So that's to enable kind of for cost effectiveness over multicast circuits that can be more expensive, like satellite. This is we don't have public spec on it, but yeah, one of the ideas is to expose the different capabilities of the underlying multicast, and to the individual needs of each of the transports. We should look into how we can leverage AMT and TreatyN most effectively.
Sure. Another question is, when to go along with Mike's exuberance about blockchain, could you tokenize, or is one of the ideas the capacity tokenizing AMT relay capabilities to provide incentives for folks to be AMT relays, and they can get compensated for AMT relay capacity that they contribute to the overall system. And I'll ask one one last question, and you can finish. Is you have today the map gateway is different than the ultimate, the end host, the eyeball, and you essentially do multicast to the map gateway, and then do like HLS, there, so that it works in the browser and stuff like that. Could you co-locate them into the same device, meaning have the map server sitting in the end host and then kind of looping back this stuff within it, so that you wouldn't even need a separate device for the map server? You could do everything in the end.
I think you mean the map gateway for your last point.
Sorry.
Yeah.
Yes, map
Yeah.
gateway.
Yeah. So first question around AMT relays. We are building. They're right now we have kind of proof of unicast delivery, and we have proof of multicast delivery, and AMT is kind of somewhere in the middle, and we're looking how we can verify that delivery, and that is technically it can be fulfilled by our multicast delivery verifications, but yeah, how actually it's billed is more like a unicast service. So I'm happy to dig into kind of how each of these delivery mechanisms and proof of delivery and settlement happens. But the answer is eventually, we will be able to have AMT relays, reporting their usage. So that is the intent. Any operator of this infrastructure, we want to keep them incentivized to run it. That's what we need for this to work. So we can't rely on the generosity of people. And we have pieces that with some modifications I think can work, but would love to dig into how we can validate and put it to the test. For your second question on Map Gateway, the idea is yes, it can be embedded into a single device. So in India, there is a kind of a project that's going on in a review of what they're calling direct to mobile broadcast. So with events like, the Indian Premier League, you have more than 400 million people who are tuning in to watch the cricket games, which is, it's a cause for concern in India that the ministry there is looking at how we can use multicast, either ATSC or cellular broadcasts to multicast direct to handsets. So the idea is the Gateway app can run on Android systems or set-top boxes, including mobile phones, and it's running in your background, translating whatever browser site or OTT app that you're using to watch that video, and that it's routing through the local host your unicast traffic through our request router. So it is something we're actively working on.
All right, we are beyond time. This is really interesting. It would be great if we had a little more technical document to read to reference through this, but you did some good QA. If there's some discussion on the list that you can facilitate, that would really be helpful.
Yeah.
Everyone have the blue sheets? Everyone sign a blue sheet? Come on, that was funny. That's as funny as we get here. All right, thanks, Omar. Thanks, everyone else. Have a wonderful week. Cheers.
Thank you.
That's the joke you should tell. That's a tourless joke.